Okay, so we previously looked at limits and looking at pictures and defining what a limit is. So now we're actually going to be looking at how to evaluate them a little bit more effectively. If you remember, if we have a limit such as this, we can't just plug in the value because the function's undefined. So how can we evaluate the limit here? Well, this is actually removable discontinuity. The denominator is a factor of x plus 3, but if I factor the numerator, I'm going to get x plus 3 times x minus 2. I can remove that factor, so I'm left with just x minus 2. And now I can plug in this value. So this limit is going to be equal to negative 3 minus 2. So this limit is equal to negative 5. That makes it a lot easier. I can still do the whole make a table of values or graph, but by just factoring and removing the common factors, it's not so much of a strain. Here, same approach. I can't plug in 1 because my denominator will be 0, but I can factor. This I'm going to have to factor by grouping. So I can factor out an x squared, so I'm left with x minus 1. Next, I could factor out a positive 1, so I get x minus 1. So I'm left with x minus 1 over x minus 1 times x squared plus 1. The x minus 1's cancel, so I actually get 1 over x squared plus 1. And so this is going to be equal to 1 over 1 squared plus 1, which is 1/2. And I would see this. So even though the function does not exist, I can plug this in and see that, yeah, wait, the limit exists. It's heading to 1/2. Now this is only going to work if it's factorable, and it won't work when the limit does not exist. So watch out, limits can still not exist, but if we can factor, it's a lot easier. So here are some problems for you to try, and so here are the solutions. So with these, we can factor this. So this is going to be, and the hint with this is, see how there's a factor of x minus 3 in the denominator? Yeah, chances are there's a factor of x minus 3 in the numerator. So that just means we're going to have this. So it must be a 2x plus 1. So we get 2 times 3 plus 1. So the limit here is 7. Over here, this is a difference of 2 squares. So we actually get x squared minus 4 times x squared plus 4 over x minus 2. And that x squared minus 4 is also a difference of 2 squares. So we get x plus 2, x minus 2, x squared plus 4 over x minus 2. The x minus 2's cancel out. And so I get x plus 2 times x squared plus 4. And so this gives me 4 times 8, which is 32. This one looks bad, but it's not so bad. So here, I'm going to have 1/2 plus negative 1/2. Oh, that's right, we can't plug it in. I'm getting ahead of myself. So we want to add these together. So this in the numerator, we need a common denominator, so I multiply the 1/2 by x over x, and I multiply the 1 over x by 2 over 2. So we actually get x over 2x plus 2 over 2x divided by x plus 2. So this is equal to x plus 2 over 2x divided by x plus 2. Remember, this is really just the same as x plus 2 over 2x times 1 over x plus 2, which we can cancel out and do 1 over 2x. We can plug in that value of negative 2 in for x, and so we get the limit is negative 1/4. A little bit of algebra maneuverings there. Here, same sort of a deal. That negative exponent, just trying to trick you up. That's 1 over x minus 2 over x minus 1/2. So we could say this is 1 over x minus 2x over x. That's an x. Over, well, we say this is 2x over 2 minus 1 over 2. So we get 1 minus 2x over x over 2x minus 1 over 2, which is 1 minus 2x over x times 2 over 2x minus 1. Notice how the 1 minus 2x and the 2x minus 1 are opposites, so I can actually factor out a negative 1 from this, and I'm left with a 2x minus 1. Oh, that's going to be a hard one in class. So we actually get negative 2 over x. We can plug in our value now, so we get is equal to negative 2 over 1/2, which is negative 4. It's a lot of algebra with that one. That was a good one. Oh boy, more fractions. So here, it's probably easier. So we're going to do 9 over 9x squared minus x squared over 9x squared over x minus 3. So this is 9 minus x squared over 9x squared. I'm just going to write times 1 over x minus 3. We can factor this to be 3 plus x, 3 minus x over 9x squared times 1 over, I'm going to factor out the negative 1 here. So I get 3 minus x. Notice those two factors are the same. So I get 3 plus x over negative 9x squared because these factors cancel out. And so I can plug in the 3. So I get 6 over negative 81, which I can reduce by factoring out a 3. I get negative 2/27. Oh, and then this one. We can't plug in 0, but why don't we try to make a common denominator? So actually what I'm going to do first is factor out an x in this denominator, so I get x plus 1. And now I can see that my common denominator is going to be x times x plus 1. So I'm going to multiply by x plus 1 there. So this is going to be 5 minus 5 times x plus 1 over x times x plus 1. I think I may have been going through this one just a little bit too quickly. Oh, no, this is right. So I can distribute this. So I get 5 minus 5x minus 5 over x times x plus 1. Notice the 5's cancel out. So I get negative 5x over x times x plus 1. But those x's can now cancel out because I have monomials. So this becomes negative 5 over x plus 1. Plug in the 0, I get negative 5. So these were some really challenging questions. This is sort of the algebra that you will be expected to do with calculus. Make sure that you are comfortable with this, but really the core concept of this is we're just evaluating limits by factoring. And, you know, all the little fun little algebraic tricks along the way.